Hey guys, here's the review for the test tomorrow. Okay, in this first problem it says simplify each. You'll notice that it's a two-term expression, and in both of these terms you have a cosine squared. This is supposed to be a theta. This is filling a theta right here. So we're going to take out a GCF. The GCF is cosine squared theta. Now if you remove cosine squared theta from the first term, you would be left with sine squared theta. If you remove cosine squared from the second term, you just can't put a 0. It's cosine squared divided by cosine squared. You have to fill in a 1. So if you look at your identity sheet, which I don't know where my identity sheet is, so to show you, oh goodness, a second, bear with me, put it under here. Where's my identity sheets? Give me a second, I'm looking, where are my identity sheets? Oh goodness, I don't know where they're at. Here, I found one. Sorry about that. All right, so your Pythagorean identity, it says sine squared minus 1. So if you had sine squared and you subtracted a 1 over here, you would have to subtract cosine squared on the other side. So this would be equal to negative cosine squared theta times cosine squared theta. So you're substituting in for this right there using your Pythagorean identity. So a positive times a negative is a negative. And looks like you have cosine to the 4th theta. Answer. This one says simplify, but it's not a simplify. It's a verify. So let's put a line down here. Sorry about that. That's okay. So this is cosine sum of two angles. So cosine sum of two angles looks like this. So you have cosine of the first angle, cosine of the second angle, minus sine, sine. Cosine, cosine, sine, sine. So it's cosine of the first angle, cosine of the second angle, minus, okay, I'm out of room now. Crap, I got to do this down here. Cosine of the first angle times cosine of the second angle minus sine of the first angle times sine of the second angle. So 3 pi over 2, I'll just go here since I have up here. Here is the ordered pair for 3 pi over 2. It's 270. So cosine of that is 0. Minus sine of 3 pi over 2 is negative 1. 0 times anything is 0. A negative times a negative is a positive, and a 1 times sine x is positive sine x, which is sine x, and you have verified it. That's what you were supposed to get. This next one is a simplify. So I think it's going to be easiest if we change this tan to sine x over cosine x, because I've done this a couple times and this just seemed to be the easiest way. So when you have to add two fractions, you have to find a common denominator. Common denominator is every factor that you see in the bottom that's different. Since cosine is different than 1 plus sine, you have to use both of these. So that's one of them, and this is one of them. These are both factors. So we have just made our denominator as 1, same one. So what is missing in the first one? It looks like we're missing a 1 plus sine x. Shoot. We're missing that in the bottom and the top. Well, it's missing in the bottom, so whatever you do at the bottom, you have to do to the top. So on the top we have sine x. All right, forget this red marker. We have sine x times 1 plus sine x. That's what our new numerator is. And then in the second one, we're missing a cosine x. So we're going to multiply top and bottom by cosine x. Because we had this, but we want this. So we're missing a cosine x. But whatever you do to the bottom, you have to do to the top. And that becomes cosine squared x. Now we're going to distribute. And that's going to be sine x plus sine squared x plus cosine squared x. That's all in the top. All over our denominator, cosine x times 1 plus sine x. Now you'll notice here that you have the Pythagorean identity right there. So what does that equal? It equals 1. So we have 1 plus sine x. That's all on the top. That's a factor. Because the reason I put that in parentheses is because it's looking like that one on the bottom. So I want to make them look exactly the same by matching their parentheses. So cancel, cancel. So what's left when you cancel everything out? Anything divided by itself is 1. So let's put a 1 on the outside. And that is 1 over cosine, which is secant. And that's your answer. So let's rope that off. Okay, 4, you sum our difference identities, find the exact value of sine of 195. I'm going to use 195. Which ones do I want to use? I'm going to use, oh no, 240 minus 45? Is that, gosh, there's got to be a better one than that. Let's see, we got 30, 60, 45. Got 120, 135. Oh, look, 135. I need to write those out. 135 and 60, but I guess you could have done like 240 minus 45. That would have given you 195 too. So you could use difference or you can use sum. We'll go with sum. 60 plus 135. That is 195 total. So sine plus sine sum is this one. Sine cosine plus cosine sine. So we have sine of 60, cosine of 135, plus cosine of 60, sine of 135. Sorry, I'm running out of room there. So sine of 60, 60, 60, 60. Here's 60's ordered pair. Sine of 60 is radical 3 over 2. Cosine of 135, that's in the second quadrant. 135, that's 45, so it's in the second quadrant, so that's negative radical 2 over 2 plus cosine 60, which is 1. Oh, you can't see my order pair. Sorry, guys. Here's my cosine. That's my 60 order pair. So cosine of 60 is 1/2, and the sine of 135 is positive radical 2 over 2. So when you multiply this, you get negative radical 6 over 4, radical 2 over 4, which equals, let's do it this way, radical 2 minus radical 6 over 4. That's how I'd write it. Half angle identities for cosine is 67.5. Well, if you double this, 67.5 times 2, let's see here, that's 0, 15, 135. So you're going to take the cosine of 135 degrees divided by 2. Now, you have to choose right off the bat here, plus or minus. That is off the original. Since cosine of 67.5 is in the first quadrant, this is positive. Square root of 1 plus cosine of the angle. So it's 1 plus cosine of 135 all over 2. I feel like this is so far away. There, is that better? Let me focus this for you guys. I feel like we're so far away. So cosine of 135 is square root of 2 over 2. All this is over 2. Make sure the radical is over the entire fraction here. This is called a complex fractions. And how do we get rid of complex fractions? We multiply everything by the LCD, which is 2. So 2 times 1 is 2. 2 times this is radical 2. 2 times 2 is 4. Then you split up the radical like this, like the bunk beds, and the square root of 4 is 2. So your answer is radical 2 plus radical 2 over 2. So this next one's kind of weird. Number 6. Cosine of 2, okay, it says, the expression here can be used to calculate the value of which of the following. This is weird. They want you to actually go, they don't want you to plug in the values for these. They want you to go backwards. So you see how it says cosine plus sine sine? Which one of these has cosine? So cosine minus, okay. Cosine plus sine sine. Cosine plus sine sine. Cosine plus sine sine. So it's this one. So we're going to make this problem look like this. We're going to make this problem right here. We're going to go backwards, and we're going to make it look like the cosine difference identity. So the cosine difference identity, they give you this problem. I'm writing this out again. So if you're going backwards, you would say the cosine difference identity is the first angle, according to this right here, because if that's a plus and this is a minus, is cosine of the first angle minus the second angle. So the first angle was 2 pi over 3, and the second angle is pi over 2, and you are subtracting these. So if I would have given you this, cosine of 2 pi over 3 minus pi over 2, you would have wrote this, cosine, cosine, cosine of the first angle, cosine of the second angle, plus sine of the first angle, sine of the second angle. But we just went backwards to its original form. Now this is 120. This is 90. 120 minus 90 is 30, so that's cosine of pi over 6, which is why the answer is A. That's a really weird problem. We haven't done any of those in class where you had to go backwards like that. So again, you're just trying to figure out which one of these is the same as this, all of this. So you could find two angles that you could add or two angles that you could subtract to get that. They picked these two angles, 2 pi over 3 minus pi over 2. If you subtract those, you get 30, which is why we picked that one. All right. Given sine is 2/3, this means you are in, let's see, cosine is negative here and here. Sine is positive here and here. So the quadrant that is both of these is the second quadrant. So in the second quadrant, sine is positive and cosine is negative. So we're in the second quadrant. So we need to draw a triangle in the second quadrant. It says sine is 2/3, so that's opposite over hypotenuse. So if you do your Pythagorean theorem, 3 squared is hypotenuse equals 2 squared plus this side right here, x squared, which by the way is going to be negative. This is 9 equals 4 plus x squared, and x squared is 5, and x is square root of 5. So this x right here is going to be negative square root of 5. That's what our x side is. And then it says find cosine of two things. They gave us sine, so I'm going to use the one that says sine. I'm using this one because they gave us sine. If you do this, you don't even need this triangle. I'm not even sure why I did the triangle. We do not need the triangle unless you're using one of these two to figure out cosine. But because I don't know why I just did this. This is extra work here. So since they gave you sine, we're just going to use the one with sine. 1 minus 2 sine squared. So let's write that. This is what cosine 2 theta is. There's 3 options. I'm choosing option number 3. So they gave us sine as 2/3. So we have 1 minus 2. Sine is 2/3. So fill in for sine theta 2/3, but you still have to square that. So 2/3 squared is 4/9. You multiply the whole number times the numerator. That's 8/9. And since 1 is really 9/9, your answer should be 1/9. Now, punch that in your calculator and see if you get the same answer. So the next one, solve over the given interval. We have number 8. Let's factor out a GCF. Okay, so I can factor this as a difference of 2 squares, like this, and set each one of these equal to 0. So when sine -1, 270, so that's 3 pi over 2. And when is sine 1, that's pi over 2. So these are your answers. Maybe you didn't like it like that. Maybe you would have, let's do that one again. Let's redo it another way. What if I added 4 to the other side first, and then divided by 4, and then square rooted, and then you put a plus minus in there. You got sine x equals plus or minus 1. Same answers, just a different way of doing it. So you can do it with factoring, or you can just do it with plain old solving. This one, we have another cosine 2x, just like this problem right here. Find cosine 2x. There's 3 options. We have this one, and this one. Which one we want to use? Well, since it has a sign in the problem, let's use the one that has the sign, which we just used it in this problem up here. Cosine 2 theta, the one with the sign. So I'm using that same one. 1 minus 2 sine squared x minus sine x equals 0. So there's the sine x. And then this is the cosine 2x. Then write your square term first. It's your quadratic term. Followed by your linear term. Followed by your constant equals 0. I don't like my first term to be negative, so I'm going to add this to the other side. I'm going to add sine to the other side, and I'm going to subtract 1 to the other side and put the 0 on the side. Factoring. 2 sine squared is 2 sine x and sine x. Factors of -1 are 1 and 1. You just have to get the signs right. It's a +1 middle, so we want our bigger product to be the positive, and we want the negative to be here. So it's 2 minus 1 is 1. Set each of those factors equal to 0. So when is sine 1/2? It says 0 to 360. That'd be 30 and 150. And when is sine -1? Down here at 270. The surveyor establishes a reference point R right here and a reference line. Then the surveyor measures the distance from the reference point to two other points P and Q. We're going to assume that this is a straight line and that this is perpendicular. I know they should probably tell you that, but we're going to assume that this reference line runs up against a perpendicular line for the surveying. So this is 90, this is 22. So what's 90 minus 22? I think it's 68. I think 60, yes, 90. And then this one is 90 and 35, so this should be 55. That's a total of 90 there, okay. So they want to know, find the distance QR, this distance right here. So you have a side and you have a side, and we are going to figure out this angle right here because this is on a straight line. So a straight line is 180 minus the 55 minus the 68. So that angle that we don't know right now is 57. Now we know SAS. That's law of cosines. So we're finding x, the side right here, is equal to 148 squared plus 215 squared minus 2 times 148 times 215 times the cosine of 57 degrees. 148 squared plus 215 squared minus 2 times 148 times 215 times cosine of 57. We're at 182.9 meters. It says show your work. I showed my work. Joanna is interested in knowing the height of a tree. So here is a tree. She is standing 8 feet away from the base of the tree on level ground. 8 feet. She notices that the angle of elevation to the top of the tree is 52 degrees. 52 degrees. The tree is leaning towards her. Crap, I already drew my tree. At an angle of 85 with respect to the ground. So what is the height of the tree? Well, we need to figure out this angle right here. So that is 180 minus 52 minus 85, which is 43. We're going to do law of sines to find this. So we have sine of 52 over x equals sine of 43 over 8. I'm punching all this in my calculator. So I got 9.2. So whether the tree is leaning or the tree is standing up, the height of the tree is the same thing, right? This is the height of the tree. So it doesn't matter if it's leaning or standing up, it's still the height of the tree. So we drew a picture. Oops, sorry, I'm like showing you things. So you drew a picture, but the tree is a tree. Whether it's angled or here, it's still a tree. And that's your answer, 9.2 feet. Explorer wants to know the width of a river. That's this. This is the width of a river. She starts by establishing points P and Q. I think we've already done this problem. That are 280 feet apart. She knows that a particular tree on the far side, right here, this is a tree, decided from point P and forms an angle of 52 degrees with the ground, PQ. All right, I just missed something here. I feel like they missed some information here. They have a 48 here, but it looks like from P it's a 48, from Q it's a 52, according to the picture. I feel like the 48 was not mentioned. It was supposed to be. So there should be a 48 in here. But anyway, they have it in the picture, so you should be good. Plus, I think we already did this problem. So we're going to figure out this angle right here. We're going to do that by taking 180 minus 48 minus 52. It's 80. So this is 80. So we're going to go sine 80 over 280 equals, how wide is the river? So we need to find the altitude. We're going to be finding this right here. But in order to find that, we have to know one of these sides of this right triangle. So we can find either side. It's up to you. Since the only thing that was given was 52, I'm using the 52. We're going to go sine of 52 over this side over here. We're going to find this side first. So we're going to go sine 52 times 280. Divided by sine 80. 224.05. So this is 224.05. So we're going to use this right triangle now. We're going to really just look at this right triangle right here to help us find this x. So we're going to go sine of 48 over x equals sine of 90, which is, this is a 90, over the 224.05 that we just found on our calculator. So we're going to use our previous answer, bring that down, and we're going to multiply it by sine of 48. Press equals, divided by sine 90, which is 1, so we really don't have to do this, but sine of 90 is 1, so it should be 166.5. And that's how wide the river is. An advertising blimp hovers over a stadium at an altitude of 125 meters. The pilot sights a tennis court at an 8 degree, okay, so he sees this tennis court down here. Tennis court, right here. Let's do a little net here. He sights a tennis court at an angle of depression. Now you have to know that angle of depression is just like angle of elevation, so it's from the top. So angle of elevation, you always use a horizontal line and then the angle that's down to the tennis court. And they said that was 8 degrees. However, if you draw a right triangle down here from the ground, using what you know from geometry class and alternate interior angles, do you see how these are parallel lines? And this is called a transversal. If it's 8 degrees there, it's 8 degrees here. Angle of depression and angle of elevation are always the same thing. Find the ground distance in a straight line. Find the ground distance, that's this, from where the blimp is hovering and the tennis court. So stadium and tennis court. So he's over a stadium. This is the stadium. And this is the tennis court. So find the distance between them. Round your answer to the nearest tenth. Do we have enough information? Well, since this is 90 and that is 8, this has to be 82 for a total of 180. You could have also found that by using this information. That's a right angle. So we have sine of 82 over x equals sine of 8 degrees over 125. So on your calculator, we're going to have sine 82 times 125 divided by sine 8. 889.4 meters. Answer. Done.